Alright, we're doing rocket science. The height of a projectile after its launch is defined by this. They want us to sketch it on a grid before we do anything else. So if you have the equation minus 4t squared plus 48t plus 3 graph. Now, they say they just want the relevant part on the grid. We're not getting a very good view of this right now, so let's think about our window settings a little more. These negative times don't make sense. Before time 0, the rocket wasn't underground tunneling its way upwards. It was just sitting there. So the interesting part starts at 0. 10 seconds might be reasonable. We'll leave that alone for now. Lowest y value that makes sense is also 0 because you're never lower than ground level in rocketry. And for the maximum, just the fact that this contains a 48 makes me think that our height is probably going to be pretty significant. I'm just going to put a 200 in there and we'll see what it does for us. I just want something that's a lot bigger than 48. Let's see what this curve looks like. Not bad. We're so close to having the entire trajectory on the screen that I'm just going to make an adjustment to make that happen. Instead of 10 seconds, let's give it 15. Wonderful. Okay, so there's our arch. If this is 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's such a good fit. I'll bet that 12 seconds is where it strikes the ground, although we'll confirm that more precisely if we can later. For now, we definitely know it produces a parabolic arc and that it hits the ground at 12:0 and it took off at 0, was it 0? Not quite. There's a little bit of a gap there, isn't there? And if you look at the equation, that isn't surprising. If you put 0 into this, you get 0 plus 3. So I actually didn't draw mine wonderfully here. This starts on the y-axis at 0, 3. So this rocket somehow was 3 meters up in the air before it even was launched. It was sitting on top of something. Find the height 3 seconds after the launch. You plug 3 into here. We're just saying the time is 3. Tell me what's happening. Plus 48t plus, 48 times 3 is what I meant, right? Plus 3. So 3 squared is 9 times 4 is negative 36. Plus 48 times 3 is 144. Plus 3. 144 minus 36 is 108. 108 plus 3 is 111 meters in the air. Find the maximum height. That would be here. What's that point called when you're doing a parabola? You remember? We call it the vertex. And we can normally find it by completing the square, but they've given me such a limited amount of space that I'm not even going to try to complete the square in there. Instead, since they wanted us to do this graphically up till now, I'm going to use calc maximum to find this point. Go second, trace, go to maximum, enter, and we're going to have it find the top of that hill. So here's a left bound, and go over to the other side. There's a right bound, and enter, and it tells us the maximum is at just barely above 6. I'm going to ignore that little bit of change in the millionth digits, and we'll just call this 6 seconds. And, I actually looked at the wrong value. The maximum happens at 6 seconds, but what is the maximum? It's 147 meters. 147 meters. Okay, D, now they finally ask how many seconds after the launch was the maximum height reached. Basically at 6 seconds. I know it said 6.000001. I'm just going to round it off. What is the height of the projectile at launch? We caught that already. 3. We find that by saying, okay, at launch means the time is 0 so far. Nothing's had any time to happen. So if you plug 0 into this original equation, it'll tell you how high you were at launch, right as the engine's lit off. And determine when the projectile hit the ground to the nearest tenth of a second. We found it already off the calculator. It was 12 seconds. If you wanted to calculate it more accurately, I'm actually going to change my window a bit here. Tell you why in a moment. Okay, there's our curve again. This is what we want to find when the object strikes the ground. So second cal can pick 0. You can get it to find where the projectile reaches 0 height, which is what we want to find here. The reason I tweaked the windows is because here it's saying left bound, put a mark to the left of that point, and now it says pick a right bound, meaning we have to move the little bug down to the right side of this intercept. We wouldn't even be able to see that if I hadn't changed the windows, but now we can see that, yeah, we're to the right, we're a little bit below. That mark will work. And it gives us the time to hit the ground was 12.06 seconds. 12.06 seconds, just a tiny bit more than 12 seconds. Now, in case you're curious, this is the height, and why doesn't it say 0? Well, basically it does. The calculator does a kind of jumping back and forth algorithm to find these solutions, and here it doesn't always land precisely on the point that you're looking for. Here, instead of 0, it landed on 1 times 10 to the minus 11th, which is 0.00000000001. And the calculator looked at that number and said, I'm supposed to be finding 0. You know what? That's close enough. So that's essentially a 0 height, and it happens at 12.06 seconds after the launch.